So still continuing with our revision on functions. So we shall attempt question 3, which you have given us m. They want us to illustrate it on a papigram. So they want us to show the relation is greater than by 3, then is a factor of. So Roman numeral number 1, attempting Roman numeral number 1. So attempting Roman numeral number 1. So we want us to show it is greater than by 3. So you can see simply the numbers given to us, analyze them and see which one has a difference of 3. So I'll put them closer to show that relationship. So this is my papigram. So given numbers 2, I can put here my 2, then I can put here 5 because there is that difference of 3. Then 2, there is that difference of 3, there is 6, 9, there's a difference of 3 still, so there is 6, 9, there is that difference of 3 which they want. Then when you look at 9 and 12, they still that difference of 2 they want. Then greater than by 3, so there is 10, 13, there is still that difference of 2 they want. So we shall just relate and see 2, 5, 6, 9, then we shall see. So 8, is there anything greater than by 3? So 8, when we add a 3, we come to 11, so we are not having a difference of 3. So we shall relate that on a papigram and see how we can go about that, because they want that statement is greater than by 3. If we look at quickly, we can see 2 is greater than by 3, then 6 is greater than by 3, like 5 is greater than by 3, this is greater than by 3, greater than by 3, also this is greater than by 3. So we can see that relation. So how can we represent this? We shall say 5 is greater than by 3, 9 is greater than by 3, then this is greater than by 3, greater than by 3, then this is also greater than by 3. Then when we look at 8 also, because when you add a 3 to 5 you get 8, so 8 is greater than by 3. This is our 5. So that is the papigram they wanted for manual number 1, manual number 2. The manual number 2, they want also a factor of. So we shall do that papigram. When we look at this, factor of is a factor, we said, is that number that divides a given number without a remainder. So we shall come to see of what they have given us, because we are seeing there are 2, 5, 6, 8, 9, 10, 12, 13. So we shall see. So 2 is a factor of itself. Then 2 is a factor of 6 as well as 8. Then 12. Then we have 10 also. Then what else do we have? We have a 5. Then we have 13. I think that is all. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7. So what are we forgetting? We're having a 9 there. 9. So we can represent it on a papigram. So we can represent and see. So every number is a factor of itself. That is true. Factor of itself. 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 Is also a factor of itself. Then 13 is also a factor of itself. So what we can begin. 2 is a factor of 6. 2 is a factor of 6. yes. 2 is a factor of 10. 2 is a factor of 12, which is true. 2 as well. 6 is a factor of 12, which is true. 6 is a factor of 12. Then 2 is still a factor of 8. Then see, this is a factor of 10. Then I think that's all we are having. Which other factor can we look at? So those are the factors we are having. So we are done with that part, because 2 is a factor of this, 2 is a factor of 6, factor of that, 5 is a factor of 10. So as well, that is what we are having for this case. So 2 is a factor of 8, 6 is a factor of this, so 2 is a factor of 12. So that's what we are having for this case. Then they want us to also find, so given that f of x is that, g of x is that, so find the value of x when f of x is 0. So Roman numeral b, Roman numeral number 1, b, Roman numeral number 1. So they're giving us f of x. Want us to find the value of x when f of x is 0, but our f of x is x plus 13. So here we shall have our x plus 13 equals to our x plus 13. Our x plus 13 will equate to 0. So roughly we shall be having our x will give us a negative 13. So then Roman number 2, they want g f of 85. So before we find the g f of 85 they want, we shall first of all find our g f of x. So looking quickly, this is a compound function, but now for us to deal with this, what shall we do? So we shall just say, we shall first look for g f of we shall look for g f of x. So our g f of x, taking note, g f of x is the same as g f of x, but we shall consider this as the child and this as the mother. So we shall take this as our controller. G is controlling, so we should know what is g of x. Our g of x is given as, our g of x was given as log 10 x plus 2. So it was given as log 10 into x plus a 2. But what are we looking for? We are looking for g f x. Taking note that this is g and this is g. Where we see x, we shall substitute there f of x. So we come here, where we see x, we put there f of x. So this will be log 10. Where we see x, we put there f of x, and our f of x was x plus 13. We can ideally see it there. So we come and say x plus 13 again plus this 2 which was there. So this will give us log 10 into x plus 15. So after finding that, then we can, after find our g f of x, we can now as well find the g f of 85 they wanted. So our g f of 85, you remember we have gotten our g f of x, which was log 10 into x plus 15. So we shall have here our g f of 85 as log 10. Where we see x, we put there 85. So this is 85 plus 15. So this will give us log 10. This plus 85 plus 15 we get 100. But further we can simplify this as log 10 power 2, because 10 power 2 is 100. Then we can drop these 2 according to rules of logarithm. Then log 10 of 10 will give us a 1, which will be a 2 times 1, giving us a 2. So that is the final answer we are having for that case. Then let us look at another question which is saying a mapping is defined by f of x is that determine the range of the mapping whose domain is this. So they have given us the domain. We are looking for the range. So in the domain we have numbers -3, 0, 1, 2. So we have -3, 0, 1, then 2. We are looking for what is in the range. Then they have given us a mapping which is f of x equaling to x squared minus x plus 3. So we are looking for what is in the range. So that is what we are looking for, what is in the range. So we shall just simply be putting in the x values in that function. So if f of x is that, then we shall just come and say f of -3 shall give us, where there is x we put there -3, -3 squared minus x is still -3 plus 3. So we have here, when you square a negative, we get a positive. Negative times a negative, still it is a positive. Now 3, still plus a 3. So this is coming to 15. So we shall put our 15 here. Yes, then what about f of 0? So you should take note, when they ask for the range, we are finding the image. Whenever you are finding the range, we just substitute in the x values, which is not for the case when we are finding the domain when we are given the range. When you are finding the domain given the range, the whole of f of x, we put there the value which is in the range. But now, since we are given the domain, we just substitute in. So f of 0 will be, where there is x, we put there our 0 squared, then minus, where there is x, we put there 0 plus a 3. This will come to a 0, 0 plus a 3 come to a 3. So this is our 3 here. What about f of 1? So here there is x, we put there 1 squared minus 1, then plus a 3. 1 squared is 1, 1. This is minus 1 plus a 3. So you also still come to a 3. Coming to a 3, so we are also having here 3. Then where there is a 2, f of 2 was given as, so we have 2 squared minus, this is a 2 plus a 3. So this is a 4 minus a 2 plus a 3. So this is 4 minus 2, which is a 2 plus a 3. We come to 5. We come to 5. So that is all we can go about that. Then the other question is asking, given that h of x is that, g of x is that, then they want h g of -2. But putting in mind, before we get g h of -2, we shall first of all look for g. We shall look for h g of x. So they want g h of -2. They want h g of -2. But we shall first of all look for h g of x. H g of x, which we don't know. So let us first look for h g of x, which is, so for h g x is the same as h g x, but where we are taking this as the child and this is the mother, so h is the controlling function. So our h of x was given initially, which was 3x minus 5. So our h of x is 3x minus 5, so which is there. So but we are looking for h g of x. So what we do, where we see this x, we shall be putting there g of x. So this is 3, but our g of x was also given somewhere as x square. x squared. So we shall come here where there is x, we put there x squared, because our g of x was given as x squared. So we put here x squared, then minus a5. So you're having there a 5, because our g x was given as x squared. That is our g x was given as x squared. So we had to substitute in, since we took this as the controlling function h of x was given as 3x minus 5. Then we are finding g of x, but where there is this x, we put there g of x. So we had to look for the x this side, and where is the x, we had to put there g of x, which was given as x squared. So our g of x is this. So from there we can find now g of negative 2, which is 3 into negative 2 squared, then minus a 5. So we come to 3. This squared will give us a 4 minus a 5. So we have 12 minus 5, which will give us a 7. That is our g of negative 2. So then they have given us, if our f of x is that, find f inverse of 11. So we cannot find the f inverse of 11 before we find the f inverse of x. So they give us that our f of x, so our f of x was given as 2x plus 5. This is part C, where we had our f of x as 2x plus 5. So 2x plus 5, we have it here. So before we shall look for the f inverse of x. So here we just let our m may be equal to 2x plus 5. Then we make x the subject. Bring 5 this side, becomes m minus 5 equals 2x. Then our x will be, that is m minus 5. We divide both sides by 2 so that we have x as our subject. Therefore, we first tell us that the f inverse of x, we shall have here, where there is m, put back our x, then over 2. Then you tell us finally that the f inverse of 11 that you wanted was 11. Where you see x, put the 11 minus 5 over 2. So this will give us 6 over 2, which will give us a 3 now. So that will be the final answer there. Then looking at this question, we have the function h of x as bx squared plus 4x. Then we want us find h of negative 1 equals to negative 3. So we wanted the value of b. So our h of x is given as bx squared plus 4x. So they said h of negative 1 is 3. So since we have this as well, we can find the value of b. So h of negative 1, we shall substitute negative 1 here. So our h of negative 1 will be, put a negative 1 here, we substitute the x value. So where there is x, we put a negative 1b into negative 1 squared plus 4 into negative 1. But h of negative 1 is 3. Then here we shall be having, when you square negative, you come to a positive, which is a 1. Times that, we have b, then minus 4. So we bring 4 this side, we have 3 plus 4. This will give us our b. So our b will come to 7.